All right, today we're going to take a pretty wild journey deep inside the human body. We are going to follow a single breath of air from the top of a mountain right down to the microscopic level of your cells to figure out exactly why high altitude can make you feel so sick. So, have you ever been up there, maybe hiking or skiing, and all of a sudden you get hit with this wave of dizziness or a pounding headache, or you just can't seem to catch your breath? It really feels like your body is failing you. But what is actually going on inside? To really get this, we're going to follow the story of a 28-year-old climber. He goes up to about 4,500 meters way too fast. And bam, he starts feeling absolutely terrible. His story is the perfect real-world example to unpack the science of altitude sickness. Okay, so here's our game plan. We'll start with what I call the pressure problem. Then we'll see how that creates a crazy traffic jam in your blood. From there, we'll look at what happens when your tissues start starving for oxygen. And finally, the cool part, how your body brilliantly fights back. First things first, let's bust a huge myth. A lot of people think there's less oxygen in the air at high altitude. That's not really true. The percentage is still about 21%, same as at sea level. The real problem isn't the amount of oxygen, it's the lack of pressure. There's just less squeeze. And it's basically a domino effect. As you go up, there's literally less air piled on top of you, so its weight, the atmospheric pressure, just drops. This means the oxygen molecules you breathe in are way more spread out. And that lower pressure in the air leads directly to lower pressure inside the tiny air sacs in your lungs. Your brain is smart, it picks up on this drop instantly, and, well, it kind of hits the panic button. The very first thing it does is yell, breathe faster, breathe deeper. This is hyperventilation. It's your body's first desperate attempt to just cram more air in to make up for that lack of pressure. And this, right here, this is the absolute heart of the problem. Even though you're breathing like you just ran a race, there simply isn't enough pressure, enough of a push to get that oxygen to move from your lungs into your bloodstream efficiently. It's kind of like trying to inflate a car tire with a tiny little bike pump. You're working like crazy, but not much is actually getting in. So, all this trouble getting oxygen into the blood, well, it creates a massive traffic jam, a huge bottleneck for the most important delivery service in your entire body. And there's a medical name for this whole situation. It's called hypoxemia. It's the direct result of that weak pressure push we just talked about. All it means is that the blood flowing through your arteries is now officially low on oxygen. And this is the condition that kicks off all the other problems. Okay, I love this analogy. Think of your red blood cells as a huge fleet of delivery trucks. Their only job is to drive to the lungs, pick up a full load of oxygen, and deliver it. Down at sea level, those trucks leave the loading dock, your lungs, packed to the brim, almost 100% full. But at high altitude, they're leaving with a bunch of empty space in the back. And you can see that drop right here. The amount of oxygen your hemoglobin is carrying just plummets. It's not that you have fewer trucks on the road, it's that every single truck is carrying a much smaller load. The entire supply chain is suddenly running on fumes. So what happens when these half-empty trucks get to their destinations, like your brain or your muscles? Well, they deliver less fuel. And that oxygen deficit is exactly what our climber is feeling. That's the dizziness, the exhaustion, and that awful feeling of not being able to catch his breath. All right, let's zoom in even further. We're going to follow one of those struggling delivery trucks all the way to its final stop. We're going down to the cellular level to see how your tissues are dealing with this oxygen famine. You know, down at sea level, your tissues are living the good life. The blood that shows up is so packed with oxygen, they just casually grab whatever they need. But at high altitude, it's a completely different story. The blood arrives with a smaller payload, so the tissues have to work way harder, basically sucking out a much higher percentage of oxygen from every single red blood cell that passes by. But here's where it gets really amazing. Your cells are ridiculously smart. They trigger this cellular emergency plan. They switch on these special proteins called hypoxia-inducible factors, or HIFs for short. These things are master regulators that can shift the cell's metabolism to an oxygen-free mode. Now, the downside is, this is way less efficient, and it creates stuff like lactate, which can cause its own set of problems. Okay, I know this all sounds pretty bad so far, right? But, and this is a big but, you should never, ever underestimate the human body. Because after it gets hammered by this oxygen crisis, it doesn't just lie down and take it. It launches this incredible multi-stage counterattack. And this counterattack happens on two totally different timelines. The immediate response, within minutes, is that hyperventilation we talked about. That's the quick and dirty fix. But the real solution, the long-term game changer, takes days, even weeks. It's a process called erythropoiesis. Your body literally starts building more red blood cells from scratch, more delivery trucks, to boost your blood's total oxygen-carrying capacity. So let's just quickly run through that whole chain of events one more time. It all starts with low-pressure air, which means less oxygen pressure in your lungs. That causes less oxygen to actually get into your blood. That's hypoxemia. From there, your red blood cells carry a smaller load to your tissues. And finally, your body fights back. First, by breathing faster, and then by building a whole new fleet of oxygen delivery trucks. I mean, it's just incredible when you trace it all out. It's this beautiful cascade of problems and solutions, all happening without you even thinking about it. We are truly amazing, adaptable machines. But it really makes you wonder. As our climber stands there on that peak, feeling dizzy but knowing his body is already fighting to adapt, where's the real limit to what we can endure?